Hello everyone. So our topic for this week is about graphing linear inequalities in two variables. But before we go there, let's try to have a review of our last topics. So in our last topics, we've discussed about linear equations in two variables, or we call this as linear function. Now in here, we have two forms. We have the standard form and the slope-intercept form. Now, since our topic for today will include linear inequalities. When we say inequalities, these are equations, but we're going to use the inequality signs. So I hope that you remember these signs. We have greater than, less than, greater than or equal, and less than or equal. Now, if we have this as the signs, instead of the equal sign, for example, we have ax plus by is greater than c. This is what we call already the linear inequality in two variables. Or either we have y is less than or equal mx plus b. That is a linear inequality in two variables. Now, when we graph linear inequalities in two variables, there would be differences when we graph linear equations in two variables. So there would be additional steps. The step one, we have to change the inequality to equal sign and graph. Now, I hope that you recall this topic, how to graph a linear equation, since we're going to use that. Now, you can use either using 2 points. We could also use x and y intercept, or we could use slope and y-intercept. For example, number 1, we have here y is greater than or equal negative x plus 4. Now, since our step 1 says we're going to change first the inequality sign with equal sign, that would become y equal to your negative x plus 4. Let's try to use the slope and y-intercept form to graph this one. Now, since we have your m, which is your slope, your m for this problem is m, that would be negative 1, and your b, which is 4, and that would give us 0, 4 as our starting point. Let's try to plot this first. So 0, 4 is located at 0, and your y is 4, so that would be here. Now, since our slope or your m is negative 1, the rise over run is negative 1 over 1. We're going to rise 1.1. We're gonna go to the left since it's negative, so that would be 1, and that would be our second point. Now, step number 2 says here that we're gonna use either a broken line or a solid line. Now, when the inequality is greater than or less than only, we're gonna use a broken line. And we're gonna use a solid line if we have or equal. So this is greater than or equal, or less than or equal. Now, what does this lines mean? Why do we have to use them? Now, when we use a broken line, it indicates that the points in the line is not included in the solution set. And the points in the line, if we use a solid line, is included in the solution set. Now, before we go there, what is this solution set? A solution set is any pair of numbers x and y that satisfies the inequality or the solution to the inequality. We have infinitely many solutions. That's why it's called a set already. So it's called a solution set. Now, for the example that I have given, uses greater than or equal. So what we're going to use is a solid line. So that would be your graph. Now, the third step is we're gonna use a test point. preferably 0 or the origin, to determine the region satisfying the inequality. The line divides the graph already into two regions. So the solution set could either be this side or either this side. Let's have the origin as a test point to find out. If it proves true, the solution set is in this area. If it's false, then it would be the other side. Since we have the inequality y is greater than or equal negative x plus 4, let's substitute 0 and 0 to find out if it satisfies this equation. So since y is 0 here, that would be 0 greater than or equal to negative, your x is 0 plus 4, that would be 0. Now, since we have the answer is 0 greater than or equal to 4, that should be false since 0 is less than 4. Since it's false inequality when we substituted a point from this area, therefore the solution set would be this area. Shade the region of the solution set. After shading the graph of the solution set or the region of the solution set, we now have this graph. So this would be the solution set of the inequality y is greater than or equal to x and negative x plus 4. Example number 2. Now for example number 2, we have 3x minus y is less than 6. I have used the x and y intercept. So in solving them, we substitute x to 0 to x. So that would be 3 times 0 minus y equals 6. That would be negative y equals 6. We divide both sides by negative 1, giving the value of our y, which is negative 6. So the first point we're gonna have is 0 and negative 6. And when y is equal to 0, the value of our x would now be 2. Since the points that we have solved are 0 and then negative 6 and 2 and then 0, graphing them now, our 0 and then negative 6 is here, and our 2, 0 is here. Since it's less than, the line that we're going to use is a broken line. The graph would already look like this, since this is less than. If we have the equation 3x minus y is less than 6, we substitute your x and y to the equation. So that would be 3 times 0 minus 0 is less than 6. So that would be 0 is less than 6. True. Therefore, the solution set of this equation or inequality is in this region. So that would be the graph already of your inequality 3x minus y is less than 6.